Good afternoon. I see the lunch attrition has already begun, so I will motor through this as quickly as possible. I was glad to hear the last speaker talking about oil and gas, and that's a subject that I'm going to dig in a little bit deeper on. I'd like to start out with a quick briefing around flares. Flares have kind of three critical operating, flares are doing three critical things out in the oil patch, particularly at the wellhead. Number one is for safety, number two is for process control, and number three is really around when you're in an operating environment where you can't get hydrocarbons to market economically, it's just a lot easier, and rather than sending oil and gas to market at a loss or rich gas to market at a loss, you burn it off on site. I'm not saying that to defend flaring, because it is an incredible waste, but I am using that as a primer to launch in to a discussion about one of the critical problems that we've identified in the oil and gas space. There's over 140 billion cubic meters of hydrocarbons flared per year globally. The opening speaker from Siemens, I believe it was, spoke about electrical requirements in Africa. That volume of hydrocarbons is enough to provide electricity for the entire continent of Africa every single year. Hone that down to the operator-producer level, that is a significant impact. That amount of hydrocarbon wasted has a significant impact on operator margins, which obviously correlates to investor returns. It's a huge safety issue on site if you're in a location where you don't have regular people going out to site visits and keep up service and maintenance. It's a political risk, and obviously there are the emissions issues associated with it. So our kind of fundamental question was really, what if in one fell swoop you could solve a number of the issues that these oil companies face in the field associated with site safety? What if you could improve site reliability, which enhances site uptime and service and the amount of oil and gas that you can produce in any given window? Similarly, what if you could do that while generating electricity, meeting your regulation requirements, and lastly, eliminating the visible flare itself? Where would this potentially be of value? Obviously, in the United States, the core oil and gas producing regions of the U.S., western Texas, in and around an area called the Permian Basin, southern Texas, down near San Antonio in an area called the Eagle Ford, and up in the northeast in the Utica Marcellus region. How do we know that this is the value? Well, I'm going to do a quick profile on one of our early customers, a group called Blackbrush. They're in a remote location near the Mexico border. There are no power lines. They're on private land, so they have to negotiate with ranch owners for site access and production rights. And it is not uncommon if you have something fail on one of these sites, a guy's got to get out in his truck and probably drive 3.5 to 4 hours to go resolve an issue. So if you're at a site where you only need 2 kilowatts of power and a guy's got to drive in his car for 4 hours to solve that problem, it's expensive. Where is this also of value? In Saudi Arabia. And this is what one of the Saudi sites looks like from the air. In Saudi Aramco parlance, they call this a GOSP, a gas and oil separation plant. And I don't think there's a pointer on here, but in the top center of the picture, you can see the main oil and gas facility, and then there's a pipe that runs down to the bottom left-hand corner of the picture where they have their existing flare stack. The little icon that you see kind of midway up on the left is where our power generating combustors are being deployed. So what's all this boiling down to? I just mentioned to you a power generating combustor, and this is what we design, build, deploy. We solve flaring problems, we solve emissions problems, we solve remote power problems, all in one fell swoop. The power generating combustor turns what used to be we call it a dumb piece of iron in a cost center into a profit center. And that is something that we have, where we found really strong value and willingness to pay from midstream operators, companies that are moving oil and gas through pipelines, and also in the actual after you've actually pulled the oil and gas out of the ground, you've got to do some work to prepare it, to put it in the pipeline to ship, and that's really the stage where we're operating. So, how are we generating electricity? We are using solid-state semiconductors called thermoelectrics that generate electricity across a temperature gradient. So the gas that would otherwise be sent to a flare, we enhance the combustion process by enclosing the combustion chamber and increasing the amount of time that these volatile hydrocarbons spend in the combustion chamber, so we can show very high efficiencies and near complete combustion. That in and of itself is not unique. There are lots of other combustor companies out in the market, and that's part of our value proposition, that we can integrate with any one of these combustor or waste destruction technologies that have already been out on the market. Our value add is putting these semiconductors into networks of heat exchangers that sit up on top of the combustors. So the hot exhaust gas that would normally just kind of go out into atmosphere instead routes through our networks of heat exchangers. The temperature gradient caused by that hot exhaust gas through our heat exchangers activates our thermoelectrics, and we generate electricity off of that temperature gradient. So, to date, the systems that we have designed and deployed are generally rated to processing between about 10,000 standard cubic feet per day up to about 75,000 standard cubic feet per day of, it's typically a mix of methane, ethane, propane, butane, the typical products that you find coming out of the ground in most of these oil and gas sites. We have work underway for larger systems that guys like Saudi Aramco are demanding, but most of the work that we do in North America is around one of these small to medium-sized devices. So, what does this mean in terms of economics? Particularly in areas like Wyoming and Colorado, we are showing paybacks of less than 3 months. That's because we are able to reduce the net emissions profile of these oil and gas sites. So oftentimes you find guys whose permits prevent them from producing any more oil and gas. Well, by making their sites more efficient, we open up the door where they can produce more oil and gas. That's why we show such an aggressive return on investment. We know that this is a big core issue for Saudi Aramco because they're looking at all sorts of other options to deal with their flare gas. This is just a quick profile of one of these typical sites that we see. The next project we have up with Saudi Aramco is for a 1/10 scale demo. That one's booked at about $160,000. We show paybacks here of about a year and a half. This is an example of what the equipment actually looks like deployed in the field. This is one of the sites down in South Texas. This, what we're really proud of, Schlumberger licensed the technology, and this is their first build up in Casper, Wyoming. And two other bits of information that are, I think, relevant. Just in the last month or so, we got a $2 million grant from the California Energy Commission. And just this week, we received notice from Energy Reductions Alberta that they will be underwriting a series of deployments of our power generating combustor technology over the next 2 years with 3 different operators that have already been confirmed, but I'm not allowed to disclose the dollar value until they announce it first. So, but it's a big one. We're excited about it. If anybody has any questions, I'm happy to take them. Thank you.